very good evening to all. Welcome back to NEET World. Today's session we are going to start chemical bonding. In chemical bonding, in today's class, we will cover why atoms generally combine and in order to get stability, and what is octet rule and duplet rule, and what is mean by valence electrons and valency, what is the difference between valence electrons and valency, formation and properties of ionic compounds, and formation and properties of covalent molecules, what are polar covalent bonds and electronegativity, and also we will see some coordinate covalent bonds with examples, and we will compare ionic and covalent compounds, how they are different from each other. See, why do atoms combine generally? Generally, everyone needs stability, right? In our day-to-day life, we will all do different works in order to get stability in our lives. Similarly, atoms also, in order to get stability, either they will lose the electrons or they will gain the electrons. Means they will lose the electrons means they will give the electrons to some other atoms, or else if they are having insufficient number of electrons, they will take the electrons from other atoms. If they are having sufficient number of electrons, then they will not react with any other atoms and they will not form any chemical bonds. So, do you understand why do atoms combine? In order to get stability. So, in order to get stability, either they will lose the electrons or they will gain the electrons. Stability eppudu vastundi? If the atoms are having sufficient number of electrons. So, in order to get sufficient number of electrons, okayala ekku unnai anukondi, they will lose. If they are having less, they will gain. Okay. So, which atoms in the periodic table they are having sufficient number of electrons? Noble gases, if you observe, they are having sufficient number of electrons, so generally they will not react with any other atoms because they are having sufficient number of electrons. So, as they are having sufficient number of electrons, they are stable. If they are stable, then why they will react with others? So, they will not form any chemical bonds. What is chemical bond first? If any two atoms, see, the attractive force that holds the bonded particles together is called as chemical bond. Means any two atoms are there, either they are sharing the electrons or one atom is giving to another and another atom is accepting. Means there is charge, positive and negative charge, right? The attraction between these two charges, these two opposite charges, we will call it as chemical bond. If you read this sentence, the attractive force that holds the bonded particles, means whatever the atoms that are involving here, those atoms, those particles are holded together because of attractive force. That attractive force generally we will call it as electrostatic attractive force, and the resultant we are calling it as chemical bond. See, we have discussed generally noble gases they are having sufficient number of electrons, right? Sufficient number of electrons ante any electrons unte we will call it as sufficient number of electrons, means then only we will call it as stable. So, here if you observe, what is the atomic number of helium? Atomic number of helium is 2, and we know already how to write the electronic configuration in KLM shells, KLMN, right? In helium, atomic number is 2, it means it is having 2 electrons. In K shell, it is having 2 electrons, it is filled, and this is the configuration, electronic configuration for helium atom. Similarly, what is the atomic number for neon? Atomic number for neon is 10, it represents, it is having 10 electrons in it. So, we can write the configuration. In K shell, we can fill 2 electrons, in L shell, 2 electrons is filled already, it means remaining 8 is filled in L shell. So, this is the electronic configuration of neon. Like that, argon atomic number is 18, In K shell we can fill 2 electrons and 8 electrons in L shell, 8 electrons in M shell. Like this we can fill the, by using electronic configuration and by using atomic number we can get to know how many electrons are there, and by that we can write the electronic configuration. Now coming to this valence electrons. Valence electrons is nothing but in the last outermost shell how many electrons are there, that we will call it as valence electrons. Means if you observe here, this is only one shell is filled and this is only the outermost shell for helium. It means valence electrons for helium is 2. Okay. Similarly, if you observe neon, configuration is 2, 8, 2 electrons are there in K shell, 8 electrons are there in L shell. This is the outermost electron configuration, means 8 electrons are there in outermost shell. This is the outermost shell, L is the outermost shell for neon. In outermost shell, L shell, it is having 8 electrons. So that 8 electrons we will call it as valence electrons. Now tell me how many electrons, valence electrons for argon. In outermost shell means M shell, K2L8M8. In M shell it is having 8 electrons, it means 8 valence electrons are there. It means valence electrons are nothing but in outermost shell, KLMN shell will write the electronic configuration. By writing the electronic configuration, in the outermost shell, last shell lo, how many electrons are there, that those number of electrons we will call it as valence electrons. So if you observe, in helium it is having 2 valence electrons. In neon it is having 8, argon, krypton, xenon, radon, everything it is having 8 electrons in its valence shell. So before this slide itself I told that they are having enough number of electrons, sufficient number of electrons, that is why generally they will not form any chemical bonds with any other atoms. It means, see, in helium it is having 2 electrons, the 2 electrons are sufficient for helium, that is why generally it will not react with any other atoms. So helium we will call it as duplet, and whereas remaining all 8 are there. 8 means octa, will generally we will say na octa. So this rule we will call it as octet rule, means in valence shell 8 electrons are there, means they will not react with any other atoms because they are having sufficient number of electrons, so they are stable. This is valence electrons. Now, so valence electrons is nothing but electrons in the outermost occupied shell. Valency means what, ma'am? Valence electrons ante outermost orbit lo n electrons unnai, those many electrons we will call it as valence electrons. These two are same? No. Valence electrons ante outermost shell lo n electrons unnai, that we are calling it as valence shell, whereas valency means the combining capacity of an atom. Combining capacity ante enti? Just now we have discussed, if there is excess number of electrons or less number of electrons than the required, than the sufficient number of electrons, ante outermost shell lo, just now we have discussed duplet and octet rule, right? Ante octet 8 kante outermost valence shell lo 8 electrons kante takku unnai anukondi, what they will do, in order to get stability they should have 8 electrons in the valence shell, right? So what they will do, if they are having less, they will try to get from another atom, right? So they will try to gain. For example, if you are taking Cl, if we will take chlorine, we will take the example of chlorine. What is the electronic configuration of chlorine? Its atomic number is 17, right? So 2, 8, 10, 10 plus again 7. In K shell it is having 2 electrons, in L shell it is having 8 electrons, in M shell it is having 7 electrons. If you observe this valence shell, outermost shell, it is having 7 electrons. So if I am asking how many valence electrons, you will say 7 valence electrons are there for chlorine atom. Now coming to the valency, it is having 7 electrons. How many electrons are less? N electrons takku unnai. In order to get stability, in order to get 8 electrons in the valence shell, 1 electron is less. So what it will do? it will gain one electron. What it will do? It will gain one electron in order to get 8 electrons in the outermost shell. So that combining capacity, one electron it is getting from another atom, right? So it is combining with another atom for that one electron. That combining capacity only we are calling it as valency. If you observe, chlorine after gaining one electron, what we will call? We will call Cl minus. We will represent with Cl minus. We will call it as anion. Anion ante enti ma? After gaining electron, one electron gaani antakante ekku electrons gaani, after gaining an electron or more than one electron, we will call that species as anion or anions, right? Similarly, if you observe what example we can take? We will take sodium. Okay, what is the electronic configuration? Sodium atomic number is 11. Its electronic configuration in K shell, L shell, M shell and N shell. If you take in K shell, its capacity is 2, so we have filled 2. Then next L shell 8, 2 plus 8, 10 completed, one more electron is remained, right? Now, how many valence electrons are there in M shell? Only one electron is there. Valence electron, how many? Outermost orbit is M shell, outermost shell is M. So it is having only one electron. We can say valence electrons in sodium is 1. Now coming to the valency, this one electron is there. So it needs 8 electron in the valence shell. So what it will do? It will gain or it will lose. See, gain ante in order to get octet, in order to satisfy the octet rule, it should get more 7 electrons, right? Gaining this kunte, if you are taking gaining, 7 electrons it will take. But if you are talking about the losing, only one electron it will lose. So no electron will be there in the M shell. So outermost will become like this. See, I will write it clearly. If we are K, L, M and N 2, 8, 1. This is a configuration for sodium. If it is losing one electron, what will happen? 2 and 8. This one will be removed. So by losing one electron, L shell will be the outermost shell. Now valence, what is it is satisfied, right? Octet configuration is satisfied. In the last shell 8 electrons unnai. So it is stable now by losing one electron. Ade manam 7 electrons gain chesese, if you want to make it to satisfy as octet configuration, but it is very hard, right? 7 electrons gain chesukodam is very difficult comparing to the loss of one electron. So generally all the metals they are ready to lose the electrons in order to get the octet, in order to satisfy the octet rule. So what is happening here? By losing one electron, sodium is getting positive charge and it is getting stable configuration. So here we are represent loss of electron is there. Loss of electrons generally we will call it as cations. The resultant species we will call it as cations. Now this is all about valence electrons and valency. See, here I have mentioned metals often attain stability by losing the valence electrons. Generally all the metals they are ready to lose the electrons in order to get the stability, and non-metals generally what they will do in order to get the stability, they will gain the electrons or sometimes they will share the electrons to get the stable configuration. For covalent compounds we have to count shared pair of electrons. This I will explain in the next slide. Now we will see the Lewis dot structures, electron dot structures. What we have to do in order to draw the Lewis dot structure? First we have to write the symbol. What we have to do first? First we have to write the symbol. Then we have to represent the valence electrons. Place the valence electrons around the symbol. This is the second step. Then we have to pair up, pairing of dots representing the shared electron pair when 2 electrons are combined. We will see the example. Take example hydrogen, we will take Okay, hydrogen, what is atomic number? 1. Then how to write the configuration? In K shell it will fill only 1 electron, right? Now if you are taking the chlorine Cl, its atomic number is 17. Okay, to get stability, first we will write the configuration K, L, M and L. 17 electrons are there, 2 electrons in K shell, 8 electrons in L shell, 8 plus 2 10 and 7 electrons in M shell. So what it will do, chlorine, just now we have discussed, it will gain 1 electron in order to get the stability. So hydrogen, what it will do, see, hydrogen and chlorine, what they will do, will represent, first we have to write the symbols of hydrogen and chlorine. How many electrons are there? Valence electrons, only 1 valence electron for hydrogen, so I will represent here. Okay. Now in chlorine 7 valence electrons are there, so we will represent that 7 valence electrons here, 1, 2, 3, 4, 5, 6 and one last electron I am mentioning here. Okay. This is the last electron. So total 7 electrons. This is Lewis dot structure. So what is happening? Hydrogen, in order to get duplet configuration, means 2 electrons in the valence shell, what it will do? It will take the electron from the chlorine. In the similar way, chlorine, in order to get octet configuration, what it will do? It will take the electron from hydrogen. So both are taking from each other. It is nothing but sharing of electrons. Okay, hydrogen and chlorine, they are sharing with each other these 2 electrons, means one pair of electrons with each other results in the formation of a covalent bond. Okay, sharing of electrons, we will call it as covalent bond. This is the Lewis dot structure for hydrochloric acid. We will see next, this is all about sharing of electrons. Okay. Next one, ionic bond or covalent bond. Ionic bond or electrovalent bond, sorry. We will call electrovalent bond, also ionic bond, both are same. So when these type of bond formed, chemical covalent bond formed generally when sharing of electrons is there. Now ionic bond is formed when one atom completely shares and whereas another atom completely accepts it, it will not share anything. Okay, one atom, it will donate completely, whatever the excess number of electrons are there, it will donate those electrons completely to the another atom, whereas another atom, it will accept those electrons, that's it. So such a type of bond we will call it as ionic bond. If you see the example, just now we have seen sodium, right? Sodium, if you see the configuration, what is the configuration again? K, L, M and N shells. Sodium atomic number is 11, 2, 8, 1. So in order to get stability, it needs octet configuration in the valence shell. So what it will do, it will lose this 1 electron. And another one is, by losing that 1 electron, what will happen? It will form Na plus and its configuration will be 2 and 8 in K shell and L shell. Now we will take chlorine atom. Chlorine, it is having 17 electrons. In K shell, it will fill 2, 8 plus 2 10 and plus 7. So in order to get stability, in order to get octet configuration, it needs 1 more electron. So it takes 1 electron and it results in the formation of Cl minus, its configuration will be 2, 8 and 8. So what is happening? Sodium, whatever the excess electron is there, that excess electron is completely donated to the Cl minus, Cl atom, and results in the formation of Cl minus ion. Whereas by donating, it is forming Na plus ion. This is cation and this is anion. If you see the statements whatever I have given here, an electrovalent bond is formed by complete transfer of electrons. ఇక్కడ sodium వచ్చేసి completely it is donating that 1 excess electron to chlorine from one atom to the another atom. The donor forms a positive ion, sodium formed positive charge, and the acceptor forms a negative ion. It formed, chlorine formed anion, negative charge. Now These oppositely charged ions are held together by strong electrostatic attraction, and that bond we are calling it as ionic bond. Okay, any doubts in ionic bond? Then moving to the next one, see I have given about sodium chloride clearly here. Sodium configuration is 281. By losing one electron it forms 2,8 configuration. Chlorine configuration is 287. By gaining one electron it forms 288. Now the two ionic species whatever is formed here, they are stable because both are having octet configuration in the valence shell. Now Na plus and Cl attract strongly and form ionic bond. Overall formula is NaCl. Now in a similar way, if you see the magnesium and chlorine, magnesium chloride, it will also form an ionic bond because magnesium, what is the atomic number ma? Its atomic number is 12, right? So configuration is, what is the configuration? Magnesium configuration is 282 in K shell, L shell and M shell. In the outermost shell it is having only 2 electrons. In order to get octet configuration, what it will do? It will lose this 2 electrons. So by losing means Mg gets plus 2 charge and 2 electrons are removed. In similar way, each magnesium chloride we are saying MgCl2. Each Cl, just now we have seen it is having atomic number 17. So one electron it is needed in order to get stability, it will form Cl minus. Whatever the electrons donated by the magnesium, those 2 electrons will be, one electron will taken by the one chlorine atom and another electron will be by the another chlorine atom. 2 chlorine atoms accept the 2 electrons from one magnesium atom. So what will happen? Results in the formation of magnesium chloride, MgCl2. The formula, so how normally we have already learned in class 9 crisscross method. Magnesium, what is the charge? Plus 2, and chlorine, what is the charge? 1 chlorine, it is having 1 minus 1. So we can write the formula like this, MgCl2, right? Now this is all about magnesium chloride. We will see one more example for ionic compound, calcium oxide. What is the atomic number of calcium? 20, right? So nearest stable gas enti ma'am? Argon is nearest stable noble gas, right? So argon atomic number is 18. So in order to get argon electronic configuration, calcium em chestundi, it is ready to lose the 2 electrons. So by losing that 2 electrons, it will get 288 as its electronic configuration. So in outermost shell it is having 8 electrons. It means by losing those 2 extra electrons it will get stability. So this is what I have represented here. Next, oxide means oxygen. What is atomic number of oxygen? 8. Its configuration is 2, 8. In K shell 2 electrons, L shell 6 electrons. So what is happening? 6 ante it needs more 2 electrons, right? So after gaining those 2 electrons, what will happen? It will get 2, 8 configuration. Ee 2 electrons ekkadi nunchi teeskuntundi idi? It is taking from calcium, whatever given by the calcium, whatever the excess electrons removed from calcium, those 2 electrons is taken by the oxygen atom. Now, so what is happening? Resultant compound is calcium oxide. Next, now what are the properties of ionic compounds? Ionic compounds, what are their properties? These ionic compounds, as they are formed due to strong electrostatic, means between the opposite charges they are forming the bond. So what will happen? Their bond is very strong. So these are generally, they are very hot and crystalline solids at room temperature. This is first point. Then next point, as they are forming very strong bonds, so what is happening? They are having high melting and boiling points. They are having high melting and boiling points due to strong electrostatic attraction. Just now we have discussed two opposite charges, so we are getting ionic bond, right? So that ionic bond, as they are having two opposite charges, that bond is very strong. As that bond is very strong, such a type of ionic compounds, they are having very high melting and boiling points. Next, in solid state, usually they will not conduct any electricity. Why? Electricity conduct avvalante what we need? We need ions, right? We need ionic movements, right? In solid state lo, we know that all the particles are arranged very tightly. In solid state, all the particles, all the atoms or molecules, they are arranged very tightly. If they are arranged very tightly in solid state, will they move? I move avakapothe, then there is no electricity conduction. So generally, as these are solids, in solid state, ionic compounds, they will not conduct the electricity. Next, they will conduct eppudu when they are dissolved in the water. Water lo dissolve aithe emotundi? They will spread, they will move here and there in ionic state, so they can conduct the electric state. Mobile mean movement. Next, many are soluble in water. Solubility depends on the type of compound and solvent. So just now we have discussed, in solid state these compounds, they will not conduct any electricity because there is no movement of ions. So when they will conduct the electricity? In molten state, means then there is liquid, or in aqueous solution or molten state where they can move little bit, right? Molten state, molten NaCl is nothing but they can move. Movement of ions can be possible somewhat. So in molten state and aqueous solution of NaCl, aqueous solution of any ionic compounds, electricity, it will conduct the electricity. Next, we have already discussed covalent compound, right? Covalent compound is nothing but sharing of electrons. Covalent compound forms due to the sharing of electrons, and each shared pair represents one covalent bond. We have already discussed hydrogen and chlorine. It is having 7 valence electrons, 1, 2, 3, 4, 5, 6 and 7th one here. Hydrogen, it is having only 1 valence electron. So by sharing 2 electrons between the hydrogen and chlorine, we are getting one covalent bond. 2 electrons are combined, 2 electrons are shared between these two, means 1 electron pair is shared, means we are getting only one covalent bond. For example, instead of this 2 electrons, means 1 electron pair, if 4 electrons are shared, it means 2 electronic pairs are shared, then one covalent bond, second covalent bond, like that. If 3 pairs are there, means for example 6 electrons are there and 2 electrons, 1 covalent bond, 2 electrons, 1 covalent bond, 2 electrons, 1 covalent. Totally we will get 3 covalent bonds. Now, so generally covalent bond occurs between the non-metals. Examples H2, Cl2, O2, N2, CH4, NH4. These we will see in detail now. First, see the chlorine molecule. See the chlorine molecule. How many electrons are there in chlorine total? 17 electrons are there. Coming to the valence electrons, 7 valence electrons are there. So what is happening? Two chlorine atoms, one chlorine atom, okay, it is having 7 valence electron, 1, 2, 3, 4, 5, 6 and 7th one I am representing here. Now another chlorine also, it is having 7 valence electron, 1, 2, 3, 4, 5, 6 and 7th one. So what will happen? In order to get stability, in order to get octet configuration, they will share these 2 electrons. They will share these 2 electrons. So what is happening? Both electrons are shared, right? So E electrons, E chloride ki, it is having 8 electrons in the valence shell. How to represent this one? See, chlorine, 2 electrons electrons here, 2 electrons here, 2 electrons here. Okay, 2 electrons are shared between them, so I will represent like this. So if you observe this one, each chlorine, it is having 8 electrons in their valence shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and for this chlorine 1, 2, 3, 4, 5, 6, 7, 8. So total 8 electrons here, 8 electrons here, like that. So whatever the electrons are shared, those shared pair of electrons we have to count for each atom whatever it is involved in the covalent bond. Now we will see one more example. Oxygen and nitrogen. Oxygen and nitrogen, we know oxygen gas formula is O2 and nitrogen formula is N2, right? So if you see here, first we will see the oxygen. What is oxygen atomic number? 8 and its configuration is 2, 6. So in outermost shell valence electrons 6 unnai kabatti it needs 2 more electrons in order to get the stability. So our 2 electrons, 2 oxygens are there, one more oxygen also, it is having configuration 2, 6, right? So these 2 oxygens, they will share 2 electrons. If you see the Lewis dot structure, you will understand it. Oxygen, this 6 electrons I will represent 1, 2, 3, 4 and another atom 1, 2, 3, 4, 6th, 5th and 6th I am keeping here, 5th and 6th I am keeping here. Okay, 1, 2, 3, 4, 5, 6 electrons in one oxygen atom, 1, 2, 3, 4, 5, 6 in another atom. So what is happening? These 4 electrons, they will form a bond like this. 2 covalent bonds are formed here, right? In oxygen atom, how many bonds are there? 2 covalent bonds are there because of 4 shared electrons or 2 pairs of shared electrons. Similarly, if you see the nitrogen atom, nitrogen, what is atomic number ma? Nitrogen, its atomic number is 7. So how can we write the configuration? 2, 5, right? Another nitrogen atom also, it is having 7 atomic number 2, 5. Now in outermost valence shell, it is having 5 electrons. So inka n electrons kavali in order to get the stability? It needs 3 more electrons. So if you write Lewis dot structure, nitrogen 1 and another nitrogen atom, 5 valence electrons, right? 1, 2, 3, 4, 5. Are you able to see? And another nitrogen also, atom also 1, 1, 2, third electron, fourth electron and fifth electron. So what is happening? These 2 electrons, these 2 electrons and these 2 electrons. Total these 6 electrons, they will form the 3 covalent bonds because they are sharing the electrons. This is all about oxygen and nitrogen gases, how they are forming. We will see the next one more example. CH4, very important ma. What is atomic number of carbon? Atomic number of carbon is 6, right? So atomic number of carbon is 6. So what is its configuration? 2, 4. In K shell 2 electrons, L shell 4 electrons. So in order to get stability, it needs more 4 electrons. So from where it will take? Hydrogen is there na? 4 hydrogens are there. Each hydrogen, it is having 1 electron in K shell, right? Those 1 electron, this 1 electron from 4 hydrogens, means 4 hydrogens, 4 electrons. Those 4 electrons are shared between carbon. So what will happen? 4 plus 4, it will get octet configuration, results in the formation of a covalent bond. 4 CH bonds will be formed. We will see the structure. Carbon, 4 electrons I am representing like this, 1, 2, 3, 4. So 4 hydrogens are there, 1 hydrogen here with 1 electron, another hydrogen here with 1 electron and another hydrogen with 1 more electron and another hydrogen with 1 electron. So what is happening? They are forming the bond. Okay, So 4 bonds, 4 covalent bonds are formed, and 4 CH covalent bonds we will call it. See one more example, ammonia, its formula is NH3. What is ammonia formula? Its formula is NH3. So what is the atomic number of nitrogen? 7. Its configuration is 2, 5. Here 5 ante it needs more 3 electrons in order to get the stability. So what it will do, it will take those 3 electrons, it will share with the 3 hydrogen atoms. We will see the structure. Nitrogen, it is having 5 valence electrons. I will write here. Nitrogen, its configuration is 2, 5. So NH3, right? So how many valence electrons are there? 5 valence electrons are there. 1 electron I am writing here, another I am writing here, and 3 electrons here. 2 more electrons I will write here. Okay. So 3 hydrogens, 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, with 1 electron each. Now what they will do? These 2 electrons, they will form 1 bond. These 2 electrons, 1 more bond. These 2 electrons, 1 more bond. 3 covalent bonds are formed. Now this extra 2 electrons are there, which are valence electrons, and not involving in the bond formation, right? Those 2 extra 2 electrons we will call it as lone pair. We will discuss in detail. So this is all about covalent bond with different examples. So in this covalent bond, we are having 2 types, polar covalent bond and non-polar covalent bond. We will see about those. What is polar covalent bond and what is non-polar covalent bond? Polar covalent bond ante, whatever the pair of electrons are shared between 2 electrons, covalent bond is formed due to the shared pair of electrons, right? So a shared pair of electrons, it can be get attracted more towards one atom and less attracted to another atom. It means, see, in covalent bond, shared pair of electrons may be attracted more strongly by only one atom. Then we will call it as polar covalent bond. Now here we are having electronegativity, tendency of an atom to attract the shared pair of electrons. We will see the example. See, here I have given HCl as example. HCl we will call it as polar bond normally. Why? Because here in hydrogen and Cl we have discussed it is a covalent bond because shared pair of electrons. So these 2 shared pair of electrons, what will happen? They will more attracted towards the chlorine. So what will happen? It will get partially negative charge. So hydrogen it will get partially positive charge. Such a type of bond we are calling it as polar covalent bond. Okay. Next, non-polar ante, non-polar covalent bond means the 2 shared pair of electrons, they are not more attracted or less attracted, equally attracted between the both the atoms. If you are taking example, okay, if you are taking the example of oxygen, okay, oxygen just now we have discussed oxygen gas, 2 oxygens are there, between 2 oxygens 2 bonds, 2 covalent bonds are formed. So these 2 covalent bonds we will call it as non-polar covalent bond. Enduku? Because both are oxygens only. So whatever the shared pair of electrons are there, they are attracted towards both the atoms equally. Okay, one atom ki ekkuva, one another atom ki takkuva kaakunda, they are attracted by the both the atoms equally. So this bond we will call it as non-polar. Whereas in HCl, chlorine is attracting more, that's why we are calling that bond as polar covalent bond. One more example also we can take H2O, water. What is happening here in covalent bond? Oxygen, it will be like this, right? Now this oxygen, what it will do? It will attract more oxygen. These two bonds, we will call it as polar covalent bond, because whatever the shared pair of electrons are there, they are not equally attracted by all the atoms. Fine. Next we will see the properties of covalent compounds. We will see the properties of covalent compounds. In properties of covalent compounds, we have already completed properties of ionic compounds. So in this, many gases, they are many compounds, whatever we are getting, they are gases and liquids, and due to shared, these atoms, these molecules are formed due to shared pair of electrons, right? So what is happening? They are having low melting solids, they are having low melting point, okay, and because these are not ionic forces, and generally they are having low melting point and low boiling point, not like ionic compounds. Ionic compounds, they are having high melting point and high boiling point. Now these are generally poor conductors of electricity because they do not contain freely mobile ions. Ionic compounds తీసుకున్నట్టే, if we are taking the ionic compounds, we are having ions. NaCl if you are taking, it will form Na plus Cl minus in the presence of water, right? It can move, those ions can move freely. But here what is happening? They will not contain freely moving ions. If freely moving ions are not there, then will they conduct the electricity? No, right? So that's why generally covalent compounds are poor conductors of electricity. And we will see the differences between ionic and covalent compounds. We will compare this once you see the slide. See, ionic and covalent compounds formation. Ionic compounds are formed generally due to transfer of electrons, whereas covalent compounds are formed due to sharing of electrons. This is the main difference between ionic and covalent compounds. Then what is next? In ionic compounds we will get ions. In covalent compounds we will get molecules. Whatever the compound we are calling, we will call it as molecules or atoms in the covalent structure. And they are having high melting point and boiling point, ionic compounds, whereas covalent compounds, they are having low melting point and boiling point. Now coming to the electrical conductivity, ionic compounds, they will conduct the electricity, whereas covalent compounds, they are poor conductors of electricity because there is no movement of ions, right? Now examples, if you are taking MgCl2, NaCl, these are the examples for ionic compounds, whereas CH4, methane, NH3, ammonia, these are the examples for covalent compounds. Now one more last bond we will see, coordinate covalent bond, okay, coordinate covalent bond. Then what is, we have completed already, covalent bond we have completed, ionic bond we have completed. Then what is this covalent coordinate covalent bond? Coordinate covalent bond, it is a covalent bond in which both the electrons of the shared pair are donated by the same atom. Just now we have discussed about ammonia Lewis dot structure. In that I have already explained you 1-2 extra electrons which are not forming, which are not participating in the bond formation, right? So once again we will take nitrogen NH3, right? Nitrogen atomic number is 7. 7 means 2, 5. 2, 5 means 5 valence electrons are there. So 2 electrons I am writing here, remaining 3 electrons, here 1, here 1, here 1, okay, and 3 hydrogens are there, each hydrogen is with 1 electron. So we will write like this, with 1 electron, okay. What is happening? It is forming covalent bond by sharing of these electrons, fine. Now these extra electrons are there, that we are calling it as lone pair. What we will call lone pair. Lone pair ante enti? The pair of electrons, the pair of valence electrons which will not participate in the bond formation. Ikkada bond formation lo they are not involving, right? So we will call it as lone pairs, lone pair of electrons. So what is happening? This lone pairs, it will be shared in coordinate covalent bond. Once again see the definition. Coordinate bond is a covalent bond in which both the electrons of the shared pair are donated by the same atom. By the nitrogen atom only, these two electrons are shared to another atom. Let's take hydrogen. Okay, these two electrons are shared to hydrogen. So what will happen? It results in the formation of NH4. One hydrogen extra is there with positive charge. So this hydrogen, it is accepting those two electrons and results in the formation of NH4 plus. See the sentences, ma? The acceptor must have an available site to accept it. Hydrogen, it is having available site to accept it. So here we will take H plus, right? Hydrogen, it is having one electron, it needs to accept two electrons. H plus means that one electron also removed. So H plus NH3 by donating two electrons, which is one lone pair. So it will donate and it will result in the formation of NH4 plus. Once formed, it behaves as a covalent bond because sharing of electrons, what is happening? Only one atom is donating. After the once the bond is formed, once the coordinate bond is formed, it behaves like a covalent bond. So we are calling it as coordinate covalent bond. And examples NH4 plus and another example is H3O plus. Lone pair, which we have discussed already. Lone pair is a pair of valence electrons not used in the formation of bond. NH3, it is having one lone pair, whereas H2O, it is having two lone pairs. How we will see. What is H2O? What is oxygen atomic number? 8. So its configuration is oxygen, its configuration is 2, 6, right? Total 8 electrons. So I will take oxygen here, those 6 electrons, 2 electrons here I will write, okay, H2O, and 2 electrons here, total 4 electrons completed, 2 more electrons will write, wait a minute. Take oxygen, okay, 2 valence electrons here, 2 electrons here, 2 electrons here, and remaining 2 electrons here, total 6 electrons. So this electron and this electron, it will form bond, covalent bond with hydrogens like this. Fine. Now these 2 extra electrons are there, here 2 and here 2, 4, total 4 electrons are there. These 4 electrons means one pair and another pair, when 2 lone pairs are there for H2O molecule on oxygen. Lone pair can be donated to form coordinate bond, just now we have seen. Now we have already seen NH4 plus formation, right? Coordinate covalent bond formation, and H3O plus also we have seen already. It means, see, one H2O molecule, H2O, it is having 2 lone pairs on oxygen. H plus accepts one lone pair of electrons from the oxygen. It results in the formation of H3O plus. Hydronium ion we have discussed in last chapter. Okay, this hydronium ion is a species responsible for the acidic character, we have already discussed. So what is happening? Whatever in these 2 on oxygen, it is having 2 lone pairs, right? So one lone pair is shared to H plus ion, results in the formation of H3O plus, and the bond we will call it as coordinate covalent bond. So this is all about today's class. Whatever we have discussed, we will do a quick revision. First, initially we have discussed what is why an atom should combine with another atom, right? Why a chemical bond should be formed between 2 atoms, right? We have discussed about formation of a chemical bond. Second thing we have discussed about stable electronic configuration. In the outermost shell, if it is having 2 electrons or 8 electrons, then it will be having stable electronic configuration. 2 electrons will be absorbed only for the helium, and remaining all we have to take 8 electrons. Octet rule we have to follow. Next, we have discussed about ionic bond, okay, which is formed by the one atom completely donates, whereas another atom completely accepts. And then we have discussed about the properties of ionic bond. After that we have discussed about covalent bond, in which shared pair of electrons takes place. And then we have discussed about coordinate bond with a different example. Coordinate bond means lone pair is donated by one atom in a molecule. And you have to, this is important to practice these different structures of different bonds, NaCl, MgCl2. Okay, NaCl and MgCl2, calcium oxide, hydrogen, chlorine, oxygen and nitrogen gases, methane, ammonia, carbon tetrachloride, CCl4, ammonium ion and hydronium ion. These all structures also we have seen already. This is all about today chemical bonding. The complete chapter is here. If you have any doubts, please let me know in the comment box. Thank you all.